G'day, my name is Bob Carrier, the inventor of the EcoShaw. It's an acronym for Environmental Cooler Optional Solar Hot Air Heater. It's a solar collector that heats your home in the wintertime using the power of the sun and air conditions your home in the summertime using, again, only the power of the sun. So it uses the sun to defeat the sun in the summertime, which is its key feature. But there are other features to the EcoShaw that I'd like to explain first. It is self-powered and self-regulating. Now how that works is we have two PV panels at both ends of the EcoShaw collector. We also have matching axial blowers that blow the air through the system. Now the way it works is these panels produce 12 volts at 15 watts. In response, the axial blower consumes 12 volts, 12 watts, and produces 120 cubic feet of air volume. The end result is the solar system, the EcoShaw, powers up on its own in the morning when the minute the sun rises, and powers itself down at nighttime when the sun goes down. But more importantly, it's self-regulated. So if a cloud goes over and casts a shadow on the EcoShaw, the collector surface cools down. However, the axial blower also slows down, and result is the output temperature remains virtually the same. It's just the air volume has been reduced. It's a matching set. End result is the EcoShaw works even on cloudy days. So how does it work? Well, the EcoShaw surface is an aluminum conductive surface that's corrugated. Air flows through it, and we've made sure that it's designed so that every square inch of the EcoShaw surface, the air gets to touch and absorb the heat or air conditioning. Now, also the way it's designed, since it is 4 feet by 24 feet, the air flows back and forth across the surface of the collector. So on a 4 foot by 24 foot EcoShaw, there's 96 feet of linear air travel. Result is that this air stays in the collector long enough to bake, which means that it operates in temperatures that are well below zero. The way it's constructed, here's an example of an EcoShaw corner frame. Since the air is moving back and forth across the collector, when it hits the inside wall, we've created and patented a vortex chamber. The air hits the vortex chamber like a skateboarder hits a slope, and it just gets it to spin and rifle itself forward, where it's spun and rifled back into the collector. So it goes back and forth, really smooth action. The purpose of that is to maintain maximum air volume at minimal air pressure across the whole surface. Now, to maintain a seal across the surface, we use EPDM rubber. EPDM is the same material that they use for the car doors. So when it's minus 40 outside your car doors, you open it and the seal returns to its natural state, so that when it's reclosed, the door becomes sealed again as it squeezes down. Even more important though, the collector surface is aluminum, so from minus 50 to plus 200 degrees Fahrenheit, that surface expands and contracts quite a bit. In this case, the EPDM seal allows for the expansion and contraction of the material so that there's no buckling and waving and so on. This is quite a bit how the furnace version works, and that is available right now. We do have, as you can see, the vortex chamber is made out of smooth aluminum to minimize the resistance for the air flow. It's also encased in foam for extra insulation, and this actually strengthens the whole frame. The outer frame, of course, is aluminum also. End result, very lightweight system that can be installed by a crew of 2 people. You don't need a crew of 6 or heavy equipment to install this large collector surface. Now, the furnace version is available right now. The air conditioning version, though not ready for production, has been tested, and it's going to be an add-on. You can add it on at any time. So you can buy the furnace version right now and add the air conditioner later on. The way the air conditioning system works, we have atomized mist sprayers that spray the surface with a fine mist of water. There's several of them across the whole surface, making sure that every square inch of the surface is sprayed with a very fine mist of water. The sun immediately starts to evaporate that water, creating that cooling effect. Same as having perfume on the back of your hand. As it evaporates, it creates a cooling effect. It's how all air conditioners work, all freezers work. Rapid evaporation, freezing. It's called latent energy transfer. Each sensor has its own moisture sensor, and it's all controlled by a microprocessor that makes sure that the surface is always the right amount of moisture to encourage rapid evaporation. Now, as it rapidly evaporates, it cools the surface of the collector. The air below it picks up that cooling effect and brings it into the house. The water is not brought into the house. The water on the surface that is evaporated gets collected, sent to a condenser. The condenser takes that vapor, water vapor, turns it back into water droplets that drop into a reservoir. The reservoir has a high pressure pump, and that high pressure pump sends the water right back to the atomized mist injector. So we're reclaiming, recycling the water as much as we can. End result is you have an EcoShaw system that works year-round, that impacts the two most expensive energy consuming items in your home or business, which is your furnace and your air conditioner. It's a worldwide application. Now we look forward to all of you who pledge with us, and thank you for your pledges. Hope you enjoy your products, and we'll look forward to hearing from your comments and to seeing you as a potential customer in the near future. Thank you. My name is Bob Carrier from Grand Point. Have a great day.